Alright, hello everyone. We got the dog shirt on, super excited. We're about to solve my favorite type of problem, backtracking. Let's get into it. LeetCode 78 subsets. So given an integer array nums of unique elements, return all possible subsets to power set. The solution must not contain any duplicate subsets and return the solution in any order. So before we get into explaining the problem, we have to know what a subset is. The LeetCode's definition is a subset of an array is a selection of elements, possibly none, of the array. So essentially what we have to do is return all subsets of the array. So as you can see in this example here, every possible permutation of this array is in the output, and the tricky one is the first one, which is none. Upon which permutation of nums could actually be choosing none of them. Hopefully that makes sense, and we're going to get into explaining the problem here. So there's a couple things I wrote down as like prerequisites. First, we're going to have a res variable. And as you can see, the output is an array with many nested arrays. So res is just going to be that one base array that we're going to be returning. Since this is recursion, we're going to be calling a function or recursive function many times. And we're going to call that DFS. And it's going to have two parameters. The first is start, which indicates what position in the array that we're going to start at and what are we going to append to our current subset. And subset, which is going to denote the current subset that we're on. So as you can see here, I wrote the first recursive call right here. And we're going to start off with a start of 0, because we're going to start at the beginning of the array, and a subset, which is an empty array, because that is the first possible permutation of the array, which is picking none of the elements. And what we're going to do is go through, append each new subset to our res array. After we explored all possible combinations starting at a certain number, we're going to pop that one off. And by the time we're done, we should have every single permutation of that array. If that doesn't make sense, we're going to get right into it, and hopefully everything is cleared up. There's going to be a lot of recursion, so I'm going to number all of my calls here, and so it's hopefully it can elucidate the process. So let's get into it. So first we're looking at our first recursive call, and as you can see, we're starting at DFS with an empty array. So first we're going to append that to our res. So we have an empty array. Next what we're going to do is we would eventually get into the for loop, and we're going to start at 0. And what we're going to do is append the start index to our current subset and call DFS again. So we have DFS, and since we appended the start index, and we're going to move the start index up, so we're going to move it up 1, and we're going to append the 0 index. So in this case, the 0 index would be a 1, so we're going to have 1 here. And I want to stop real quick and explain why we're moving up the start index. If we didn't do that, we'd end up picking the same index over and over and over again, and that's not what we want. We're going to move up through the array. So now that we're in this recursive call, we're going to append our current subset to our res. So we're going to have a 1 here, and we're going to get into the for loop, and we're going to be in the third recursive call. And we're going to call DFS again, same exact story. We're going to move the 1, our start index up 1, and we're going to append whatever index that we started at. So you can see this is a 1. We look at the first index, which is a 2, and we're going to append that right on. So we're going to have a 1, 2, and we're going to call that. We call that, we're going to append it to our res, so 1, 2. And this is where it gets a little tricky. When I first started, this was definitely a bit of a problem. As you can see, during this recursive call, we actually cannot go into the for loop because as you see, the start index is 2, and there is no, our array only goes up to index 1, 0, and 1. So we're actually going to end this call because there's nothing more we can do, and we're going to recurse back up to the second call. And as you can see, we explored that one pretty much fully. So what we're going to do here is pop off our index because we've explored every possible combination or permutation from starting index of 0. So what we're going to do here is I'm going to call this one 2A to denote that we're back at the second recursive call. It's not a brand new one, but we are doing something different. And what we're going to do is pop off our index. So we're going to have the 1 here, and we're going to pop that off and have a empty array here. That ends that call, so we're going to recurse back up to the first DFS call. And I'm going to denote that here. I'm going to put a 1A here. 1A. And the only difference here now is we're starting off at index 0, but since it's in a for loop, we're on the next iteration. So now we're in the first call, second iteration, so we're going to have a 1 now, and we're going to append that to our subset. And if you look at index 1, that would be a 2. We're going to append that on. We're going to call that, and as you see, we're going to do the same exact thing. We're going to append our subset to our array. And that's the last call because we're at a 1. That's the last index, and the program would end. And as you can see, our res array is eerily similar to output array, and this is every permutation of the array, and that's how you do it. Now we're going to get into the code. So it's actually pretty simple. So we're going to start off with a res array. Next, we're going to define our function called DFS. This is going to take two things, so the start and our current subset. Next, we're going to go res.append subset. And this is just denoting that we're going to copy the subset over to the res array because arrays are stored by reference, not value. We don't want to change the value. We want to get a fresh copy into our res array. Next, we're going to create our for loop. So for I in range, and we're going to start off at start. And we're going to go until the length of nums. And we're going to say subset.append, and we're going to add nums of I. So whatever I is, we want to add that to our current subset. Next, we want to call our DFS function, but instead of doing I again, we're going to do I plus 1. So in the first iteration, as you saw, we went from 0 to 1. That's what we're doing here, adding plus 1. And we just appended to our subset, so we're going to add subset here with our new value. And once all these recursive calls are done, we've explored every possible combination starting at whatever I was. So we're going to go subset.pop and pop the last one off. And this should be good. So first, all we have to do is call the function. So we're going to say DFS, and I have a start of 0 and a base array, which is just an empty array. We're going to call that, and all we have to do is return res. And this should work. Let's try it out. Oh, there we go. And we solved LeetCode 78, and it's pretty fast and pretty efficient. Hope you guys enjoyed the video. Peace.